Okay, I see it on the top.
Yeah, we are live. Thanks for reminding me. So, introduction to machine learning. So this is going to be a more. We're going to try to have more of a chill day, trying to understand, trying to talk about machine learning, and this slide is from Google AI, so it's really high quality and it's fun. So let's get into it. So actually, this is the first thing. It's a little video on what is machine learning.
Our ability to learn and get better.
Yo, can you hear it, by the way?
Yep.
Yep. Everyone good?
Better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognize a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organizing it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course, there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning.
So actually, normally I like to talk, but I couldn't say it better than Oxford Sparks did, and I love that animation. I don't know about you guys. I think animating's awesome. But yeah, so I mean that's the base of it, and I know that you guys already pretty much know this, so nothing new. But yeah, let's just get right into it. So this part is interactive. We can do this together. So this is QuickDraw, and it's by Google AI. And I'll share my screen doing it so that we can all see how it works. It's really cool. It's crazy. Like I can't really explain it until you see it. So let me.
This is so fun, by the way.
Oh, really?
Yeah, I've tried this before. I think Clement
never
sent
seen
it.
this.
Dude, it's so fun.
I know. I love this. I found out about it, and it's crazy. So
this is how you get good at Scribbler.
Yeah, this is how you train. You train that'd be an interesting project, actually, training a model to be good at Scribble.io. But yeah, so Draw Golf Club. Please don't roast my skills. I am terrible at drawing, but you'll still recognize it, hopefully.
I got all the faith.
I see knee, or street light, or spoon, or baseball bat. I see nail, or boomerang, or matches, or camel. I see popsicle, or hammer, or pliers.
Okay.
Sorry, I couldn't get it.
Yeah, that's the thing. I'm terrible at drawing. So even AI couldn't figure it out. But that shows you though. This is still a real-time learning thing. And because there's so many different aspects, because in human creativity, there's different ways we express things, right? So like, I'll show more examples later, but let me first finish this and I'll show you. So a star, this one,
I see triangle. Oh, I know. It's star.
you see that one guesses it right away. I mean, it takes 3 seconds. And also what I like from this is, I don't know if you guys can hear, it's talking back. It's saying, you know, I think it's, I see bike, I see bed. And it's really cool because you can actually see the model trying to predict it in real time. So from little lines, sometimes I can even predict, and with stars, I didn't even draw the full shape, but it's seen it so many times that it knows it, you know, or it can recognize it. So trombone, oh, this is gonna be terrible.
I see line, or garden hose, or toothbrush. I see spoon, or shoe, or hockey stick. I see snake, or swan, or string bean.
Yeah.
Clarinet.
A trumpet with a long.
Bro, what the heck are you
Oh
drawing?
no,
man?
this is,
You got that. You got that.
Snail. A butterfly.
Sorry, I couldn't guess it.
okay, that one was kind of difficult. I mean,
Yeah, you got a long one.
yeah,
Oh, no, that was tough.
campfire. I think we got this. Let's see. Campfire.
I see string bean, or lightning, or zigzag, or crocodile. I see octopus. Oh, I know. It's campfire.
You see, again, super fast. And campfire is a difficult one because, you know, it's not an easy shape to recognize. But machine learning doesn't even have to think about it. It's like the lines it sees, it doesn't recognize, oh, that's this. It just knows it from experience and labeling. So nose. Okay, I got this one for for sure. For sure.
Oh, I know. It's nose.
There you go. You see, and if you think about it, that was really interesting because it's almost just like an L, and it knows it's a nose, or it can guess that it's a nose. It's really interesting. So, last one, washing machine, and then we'll see how we did.
I see line. I see square, or elbow. Oh, I know. It's
Boom.
washing machine.
Washing machine. You see, so I did butcher 2 of them. That's my fault, not the models. Even though the model is still constantly training, and I'll show you the data. But so we could see the golf clubs couldn't figure it out. The trombone couldn't figure it out. I wouldn't figure it out either. I don't blame it. Before we go into the data, any feedback? Is it cool?
I think this is awesome, and also that your data is going to be super helpful.
This,
Trombone.
I didn't know something like this existed. It's cool.
Yeah, exactly. So, do you guys kind of understand? I mean, it's easy to understand because it's so visual, but you see how it's able. What's really cool about it is if you think about it, it's just lines, right? And for our brain, it's very easy to identify because we've been, you know, doing it for years, and brain is really superior. But let's see the data. Let's see. Okay, so this is my favorite part actually. Let's see, what do you guys want to pick one of these so we can look further into it? Anybody?
Uh,
The angel.
The angel?
I'm singing the same, Danny. I like that.
Ah, you guys like the angel. Okay, let's go into the
Dude, that's a perfect airplane on the left.
yeah. So
Wow.
look at this. This is 127 and a bit more thousand angel drawings. And so what happens is when you're playing this game, you're actually feeding the system data, which is normally extremely difficult to get because normally you have to hand label everything. And how they started doing this is they originally trained it on their own labeled data. So it starts to recognize a bit more. And then they started making this open source. And I mean, you can really see, look, as you hover, you can even see how people start drawing it, which I think is super cool. You see? Or if I go down, everything loads. So you're feeding the data, which is really important in machine learning. You want a lot of data, because the more data you feed your model, obviously it's not direct relationship, but normally it starts to become more accurate if you feed it good data, and yeah, it learns more experience, if you want to think of it like that. And so so you might be thinking, well, we're feeding this data, but what if for Angel or for Golf Club, I'm a terrible drawer, as we saw, and I feed it what looks like 2 AirPods, right? It's maybe, what if I confuse the system? Well, first off, there's a lot of data. As you can see, there's in the hundreds of thousands, and sometimes even more. So it's not going to necessarily confuse just by my one drawing, but if it starts happening on a large basis, it can create bias. You know, if instead of Golf Club, we draw a circle with a triangle on top, if 100,000 people draw it, it's going to start thinking that that's a golf club, right? And so you would have to fix that. And in here, they have a very, very interesting system where, for example, this one, I don't know if I would count that as an angel. I don't know about you guys, but so we could pick something like this, which would be like an outlier. And well, this one, you don't really have to flag it, but if it really is nothing like an angel, so not even a figure or anything, you could even flag so that they can see, okay, we might have to remove that so it doesn't mess up the system. And it's really cool. You can see from where they come from. So Lithuania, I saw Switzerland earlier, Slovakia, United States. Let's do one more. So Poland. And it gives you the date and everything. So, but not yet though. Not done yet. Let's do another one. You guys choose. I don't know if you can see all of it.
Wait, can you go to Golf Club?
Golf Club? Let's see, where is that?
Yeah, you can find it.
Okay, let's see.
I think they're advertised, to be honest with you.
Right here. Let's see. It's gonna make me feel dumb. Hey, to be fair, mine was a little better than.
Dude, there's a hockey stick in there, bro.
Yeah. Yeah, you see, and look, a flag.
They kind of all
Bro, there's a straight rectangle in that same column. Like that.
You started seeing, and this is all data that we're putting in this model, which, by the way, is a CNN, which stands for convolutional neural network. It's normally the one that we use for pictures. That's the main use of a CNN. It's really good at identifying pictures. Yeah.
Do you think the issue why you it didn't get it for your drawing is because most of these data, it looks like the golf club is facing to the bottom and you drew it facing to the top?
It very well could be. You see, and thank you for bringing that up. That's really interesting to think about. That, yeah, and especially because I probably made my stick part too thick. So all of these things, they add up. You know, if the majority is one like this, then it's not going to guess mine, right? But I'm sure that if you had, for example, 500,000 of these, I think that it could recognize my drawing as a golf club, even if it's terrible. See, so let's do one more. Unless you guys are bored by it, it's cool too. Let's see. Anybody?
There was an elephant somewhere. It was
Elephant.
like more up.
Oh, look at that bunny. That's a
Wait.
really good bunny.
Wait, go up a little bit. Go up. No, there's like little with a mustache. Oh wait, it's all the way at the bottom. At the bottom.
Oh, you mean? Oh, yeah. You mean like? Is it somewhere on this?
That one seems more. That seems more interesting. It's like at the bottom right.
Bottom.
With the mustache.
Yeah. Wait, my camera is blocking it. Let's see. Is it on this page? Do you see it?
Yeah, like all the way at the bottom right.
Oh, right here.
Yeah, that guy.
Mustache. Oh, that seems like a fun one to do, right? Okay, so you see, there's some strange ones. There's some really good ones. Like this one, it's really good, and then this one's almost good. But you start seeing, this is really cool to see human bias into models. So luckily, the Google engineers that did this, they're very smart and they know how to deal with this. But for example, this is really good because it is a mustache. It's not necessarily just a mustache. So by creating an entire face, it could throw off the prediction. But then again, if a lot of people start doing this, where they do the whole face and the mustache, your model starts being able to identify on a face, a cartoon face, the feature that is the mustache. So yeah. Just wanted to show you guys this, and if you want, I definitely recommend holding this. Excuse me. When you press get the data, you're led to their GitHub, and let's see. Yeah, so their GitHub is really good. They have a really good README. And if you guys are unfamiliar with GitHub, it's no worries. You can always reach out to me. I can try to explain. There's really good videos online. But so what I wanted to highlight from this, you could see what they talk about, and you can actually get the data itself. So it has, let's see, yeah. So just, this is one of the data sets that comes from this, and it has 75,000 samples, which is pretty decent. But let me see, there's here. So 50 million drawings. A data set like that, you're not gonna find, you're gonna find that very rarely, because it's so much data to make sure that it's right and everything. So, and it's even categorized. So you can actually get this data for your projects, and some of the projects that people are doing, it's really interesting. I recommend that you guys look at this. I'll click on one, just so infinite QuickDraw, just to show you. So what they're doing here is they're actually adding, so this is a model, and it's just drawing indefinitely. And you'll see that all of these drawings are nonsense. They rarely tie to anything. But there's also mutational. So there's two modes where it starts building on itself rather than just building. So yeah, I thought that was cool. But we shall go back. Let me see if I can send you guys the link. Never mind. Well, because I can't really reach the chat. Oh, I can. Oops. Oh yeah, and then Aldo, thanks, man. I really appreciate it. Sending me the link. And if you have anything in the chat, sure, because yeah, that's true, Raphael. Because you only have 20 seconds, it also adds. I think they did that not only because they want fast data and they want people but your first instinct to what a mustache might look like or a star might look like might be the best guess. You know? So, yeah, and sorry if I don't see the chat. Normally we have 2 people, so we can check one another, but I can't really see it when you do. So if you have anything, please speak out, or I'll try to keep track of the chat. Okay.
I'll be monitoring chat too, just in case of anything.
Okay.
Yeah, but wait, I did have a question. So you were mentioning about like the drawings, how they get like thousands or hundreds or millions of drawings, right? But the AI, is it tracking like 10 like location, like where, how is it like I know that the orientation of the images are that's what they're recording, but is it taken into like a, what I'm trying to say is like like X and Y like coordinates? Is that how they're like inputting the data, like in terms of numbers, or how are they able to recognize that?
That's a good question. So how it saves the data, I'm guessing, is what you're asking. How
Yeah,
the data for the
yeah. How's the data process?
Yeah. So, well, what we can see is the part that I'm not fully sure about is when you hover over, let's do alarm clock. When you hover over it, that it restarts and it shows you what the process that the person drew in. That I'm not really sure how they capture, but what I'm fairly confident in is what they do is they capture the image itself. So what's good about having a website like this is you get to have more or less a uniform image width, which is very important in models and in training models. You need to make sure that everything is uniform because you want to be able to feed in a system where if you don't have a uniform, the math is not going to work and it's going to be all messed up. But so then to answer your question, so what it does is it takes a picture and it processes it through a CNN, which that's what a CNN does. There's a few techniques, but the main one is the sliding window. And so it's kind of hard to explain without a diagram. But in very simple terms, it takes the image and it will take parts of it and then run it through the layers to be able to train it to identify something, right? So does that answer your question?
Yeah, that's great.
Good.
Thank you so much.
Yeah, thanks for asking, and feel free, anybody who wants to ask. I'm free. Let me check the chat. Monitoring. Yes, definitely. I like your use of emojis. That's some emoji code right there. Yeah, so let's keep going. I kind of jumped the gun on this. You know, how does this game work? And well, you saw how the game works. You draw, and I mean, I preferred showing you guys. I think it's a lot easier to see it visually than explain it. But yeah, so here's a question. How could we program this? Does anybody have any guesses? I don't even have an answer, but I think it'd be nice to have an idea.
I'll give it a shot.
No,
Have money, hire Google engineers.
that's a smart.
Look through every single image and then replicate it.
Yeah. That could definitely work. You see, I mean, I think just in itself, it's difficult to set up something to sketch in. You know, especially it looks really clean, which we can always appreciate from Google.
Supervised or unsupervised learning?
It's supervised because initially you had to label the data. So like I was saying earlier, because you can't just have a model and then like they didn't take the non-trained model and just put it on the internet and people started feeding it pictures. They needed to make sketches, label them, and then train them, and then it starts just classifying. So it still is supervised, because while you're not writing the labels and you're not saying, okay, I make sure that this is, normally you would make sure that the image that is labeled is for sure that, right? But what they're doing here is they're creating the labeled data, because I get snail, I draw a snail, and it'll take the image. This is perfectly good data, and it's labeled snail. So you have it labeled. It's just automatically labeled, and that's actually what's so incredible about this implementation.
So Google would automatically just label it. Oh, this is a doodle. So we already have that.
Yeah.
Perfect.
Like, I don't know exactly how they programmed it to do, but they definitely already labeled it, because they're telling you, they're saying, you know, draw an alarm, draw a snail. So it's just, it's a bit risky, because you're assuming that people are gonna follow the rules, which is,
so if enough people assume that they can just draw like Leonardo da Vinci, they can mess up the code. They can mess up the program. Perfect. Let's go, guys.
yeah, let's do it. No, I think it would. Knowing Google, I'm sure that they have a way to detect if it starts going off rail.
Yeah, no, definitely. They probably have outlier normalization.
Yeah, exactly. So probably wouldn't work, but in theory, it could work. If you have enough people that it just overruns the data, it could totally classify something else. Like I said, the circle and the triangle. But yeah. So any more questions?
Wait, yeah. I'm pretty sure we can what's the word I'm looking for? Improve on the data we have if there were just to resize and crop it, and also like put it as an angle as well. And then at that point, probably what you would have drawn, they would have gotten it as golf club, right?
Yeah, it definitely could. I'm sure that there are ways to optimize, like to. It's always difficult, because I mean, I'm assuming all of us are programmers or know a bit about programming, and when we're programming, especially when it's human interacted programs, you always have to assume the worst of people, right? But it's difficult to account human intervention into something. So like, maybe I draw my golf clubs upside down, you know? So yeah, that's very true, Lazarus. You could probably optimize it. So yeah. Anything else? Good?
Gucci.
Okay, we're good. Let me check chat real quick. Make sure. Leave them. Sorry. Yeah. Okay. So yeah. So I mean, I already went very in depth into this, but this is the carrot example. They have the carrot, and we'll see. Look. So here's the difference. If we had QuickDraw in a rule-based manner. By the way, can you guys see, or do you see the cameras when I'm sharing my screen?
Yeah.
Okay. Cool. Let me move my cameras for a second. So here we're looking at code. So like these are just if statements, and it's just pseudocode. It doesn't really matter what it says, but the point of this is, if it's rule-based, where it's just programmed, you say, okay, well, if this object is this height, if there's this color, if it has this number of legs, classify it, what's, I don't know, like a dwarf, or like a dragon or something, some mythical creature. You're gonna, you have it very first off, you would have to make a lot of rules to classify a lot of things, right? And you're kind of narrowing it down because what if I make my dragons with 4 legs instead of 2? Doesn't mean it's not a dragon, or a dragon might be a difficult thing because it's not actually real. Let's say an apple. If I draw my apple red, and I set the object color to be green, right? We run into these issues, and this is why ML is useful, because you're not training on rules. You're not saying if this, if that. You're not stopping yourself from from human thought and logic. So what you're doing is you're training with examples. You have all these carrots. They're all varying carrots. You have some really nicely drawn, and then you have some that kind of look like turnips. And that's not an issue because there are different shapes of carrots. But you're training with examples that are labeled, and you're saying, okay, well, here is this picture, have it, and this is a carrot. And so the model is going to be like, okay, this is a carrot, and it's going to get a lot of carrots, and then you draw something that kind of looks like a carrot. It'll say, I know that is a carrot. It's funny because machine learning and AI is supposed to almost reflect off of us and our brain, so it seems very human. But yeah, I'm going on a tangent. Everybody understand that, like the difference?
Yes.
Yes. See, Aldo got it. Let me check the chat. Yeah, dragons. You're right, Aldo. You weren't supposed to tell them. Dragons are real. Sorry.
By the way, going off on tangents is fun.
Wait, what did you say, Dan?
No, because you were saying that you were going off on a tangent, but going off on tangents is fine. It's interesting sometimes.
Sometimes, but with me, my tangents, I get caught up. But I guess that's what this dev community is about. Going on tangents. That's normally when the information you absorb it the most, right?
Bro, we're being so meta right now. Like, you're going off on a tangent on going off on a tangent. I love this. This is what I live for.
That is, hey, you'll only see that here. Meta. But let's see. Okay. Okay, so we go into our stuff. So what approach do you think you have to use for alphabetizing a list of song titles? Which one is the best method?
Yeah, we're gonna need a $1 million AI for that.
Exactly. No. Well, okay. Let's see. Well, so we're saying that
rules-based approach.
Rules-based approach.
Rules for sure.
For sure. Okay, let's check it out. We need that milk.
I'm not so sure.
No, yeah.
At least initially.
Because you don't alphabetizing is something that doesn't have a lot of nuance to it. The alphabet is already set. It's A through Z. So you don't really need a machine learning model to start learning the things. You just say, you just say use normal code. So let's keep going. Let's see. So ranking web search results. Which one is this one?
Rules-based.
ML.
And actually, if you guys can, go to annotate. Let me give you a second. Go to annotate. Go to stamps. Pick the little check mark. Oh yeah. Let's see, a little check mark, and just put 1 on which one you think. We'll see.
Wait, How do you do it?
It should be an annotate. Trying to.
And it's on the top right.
Oh God.
So you should see a view. Well, I mean, if you're on PC, it should be on top. It's view options and then annotate.
Yeah. You can also do
I
drawing.
was sorry, I was AFK, Hermes, when you mentioned like the difference. Can you give like a quick definition on both?
Yeah, sure. So rule-based approach, think of it very plainly as you're coding it out. You're coding, you're saying in the code, if this or alphabetize this, like you create a function for it and so on and so forth. And then machine learning, you're training a model on experience. You're giving it data. And it depends on how you want to train it, but in our case, we'll say supervised learning, and we say, okay, Giovanni net. Well, we'll say net because normally if you name a system, you say net or coral net, something like that. So Giovanni net, here is a picture of a carrot, and then you'll say, well, I still don't know what a carrot looks like because there's only one picture. But as I give you more pictures, you're gonna get really good at classifying carrots, right? But yeah, those are the two differences. Does it make sense?
Yeah, thank you.
So, David, he found a secret. Is that Among Us? Or, well, we'll see.
Well, we can draw.
Yeah. So
I didn't mean to do that.
Let's see. Who said both?
I did.
And I stole that idea as well because he actually has a point.
So wait, who said it? So Daniel Ortiz and David?
Rafael.
Oh, sorry, because I can't see all your screens. So, okay. Well, let me tell you. Actually, it is both. This is a bit tricky, so I'm sorry for that. But it can be both because you can make ranking web search results. You can make it rule based, and you can say, well, based on this thing. And no, don't worry. This not a problem being wrong at all. In fact, no one was wrong here really because both work. Because yeah, so you can do rank web search results based on different metrics just by coding it. But of course, machine learning works very well because you're recognizing patterns, right? Or you're trying to get a model to recognize something that you want, right? And so yeah, it's very good. Thanks guys for participating. We have a few more, so don't worry. Let me just
real quick, just could you argue that like the best, I mean, one of the best ways to approach it could be, for example, rank ordering for rule based. In the case of rule based, you could just do it based on like the most common search results, and then include machine learning for patterns that Google recognizes outside of the search box, such as like your individual interests outside of it.
Google does use both.
Right.
Go ahead. Yeah. And so wait, who had asked that? Was it Daniel?
Yeah.
Yeah. Okay. So yeah, actually, you can use both, and it doesn't have to be binary where you say, well, it has to be rules based or it has to be machine learning based. No, you can use both. But so you were saying that you could set up rules like what is the most common search, and that's very logical. But then when we're dealing with human behavior, it's normally a lot more complex than just there's a lot of factors to it. So sometimes you can have a higher number of searches based on time of day, and I know that's not the best one of nuance, but there's some smaller, more precise things, as companies start to get really big and have a lot of funding to try to put out marketing. You really look for tiny details that will make a big difference, right? So yeah, you're totally right. So the next one, predicting house prices based on location. Let's see, what you guys think? Oh, that machine learning. Let's see, Rafael says machine learning. Czar, Aldo. Yeah, very true, David. Giovanni. Oh, Giovanni twice. He's really sure about this one. Okay. Is that everyone? Yeah. Yeah, you guys actually got this on point. I don't know if I would have, when I started out, or I knew a lot less. Not saying that I know an incredible amount. It's always with machine learning. I'm going on a tangent again, but machine learning, you can. There's very varying degrees. You can start off and be fine and learn really a lot, and then you can get super complicated. And I really like that about machine learning. But anyways, I'm getting off track. So yeah, it is machine learning because it's something that has a lot more details to it, right? Like I said, nuances. You're taking in consideration a lot more factors, because you're including location and the houses around it and so on. Now, I'm sure that there would be a way to do it rule-based. It just wouldn't be the most optimal way to do a program and to predict house prices. So yeah, machine learning definitely takes the cake on this one. Okay, we have two more. Let's see, let me clear this out real quick. Okay, what do you guys think? Processing online payments. So this is processing the online payments. Okay, I see Rafael and Daniel going between. Oh, is that in between Rafael or?
Yes.
Yes. Okay. So Rafael says again both. It could be. I don't know. Oh, okay. He changed. So David says both. And I see.
Actually, when you say processing online payments, what do you mean?
Well, that's as.
Because I know for a fact that when it comes to detecting money laundering, they do use ML.
Yeah, for sure. And that's actually in the video that you guys watched. You saw it. You even heard about credit card fraud. And that is something that machine learning is much better than rule-based approach. I can almost guarantee it. And that actually is something that we're looking into. I'll do a quick announcement right now about dev communities, because as you know, this is the final dev community for the semester, because we're gonna have finals, and I have even a test tomorrow. Struggling out here. But so we're looking into. I know now that we're kind of in the beginning stages of trying to understand, and even the beginning stages can be super interesting. I still love learning about it. We will try to go into more complex things and applications, and we'll let you know more. But we have organized it, John and myself. We've already organized a really good schedule, so we'll tell you more about that. Let's see. So processing online payments. So you are right, Rafael, where machine learning is definitely used for fraud, but in this case, we're only talking about just processing online payments. So the regular stuff, the coding, and you don't need machine learning for that. But it's good that Rafael brought it up, that you can just also add machine learning to it. So you have processing online payments, and while that can go through and so on, but maybe you can have a model that checks if the credit card is fraudulent, or it has been used in too many similar transactions or something like that. So definitely can use machine learning. So good job, guys. And last one. Let's see if you guys can do this. Classifying an object in a photo. Now, I don't know, this one's difficult. Oh, Daniel really thinks it's rule-based. Okay, let's see. Oh, he doesn't think that anymore, apparently. Oh, Rafael, he's not sure. C. Yes. Yeah, well, and that's actually interesting that you bring up human eyeballs. I think that was Aldo. Was it Aldo?
Yeah.
Yeah, because I recognize the color. Okay, let me give a few seconds for people to guess it. Let us see. By the way, for
Wait, what? Oh no, I didn't bring that. I drew that. Sorry.
Are we gonna mention the protein folding thing, by the way? That was pretty badass.
Oh, we definitely could talk about it. I didn't even fully look at the article, so
No, me neither. Don't worry.
yeah,
That's
but
extra credit.
But actually, I'm on a research team, and they do a lot with proteins and stuff. And actually, ML is used a lot in like biomed, and it's really cool. There's a lot of applications. So I hope you guys keep this passion of yours into it. Let's see. So I also want to say hi, Gabriella. Hi, Clement. Sorry, you guys weren't in the beginning, so I didn't really get to see you guys. And yeah, and I think that's everyone that I missed. Okay, let us see what this could be. It is machine learning, and this is one of the clearest examples of use of machine learning. This is one of the most common things you'll see. It's called computer vision. And so like QuickDraw, we use machine learning. And I saw, I think it was Rafael, you wrote CNN. Is that true?
What did you say? You cut out there?
Oh, were you the one who drew CNN inside the box?
No, not me.
No, was it David?
No.
Daniel.
It was
Did I
you.
get called on by the teacher?
Yeah. Yes.
Sorry.
No. So
What happened?
No, I said, were you the one who drew CNN inside the box?
CNN? No.
No. Well, hey, I guess mystery person, unless they want to say who it is.
You said it, no, Hermes?
I mean,
It was someone with the purple. Who has the purple?
Yeah, I didn't write it. Somebody wrote it, but anyways, whoever you are totally right. It is one type of architecture that you can use for classifying an object in a photo is CNN. And that's what QuickDraw was doing, the thing that I showed you earlier. So yeah, this is definitely a good application. And quick fact, CNN is actually trying to mimic the human eye and how it processes things. Excuse me. And if you notice a trend with machine learning, it's trying to simulate like humans. So, CNNs or your eye. Oh yeah, go ahead, Giovanni.
We're starting to get into deep learning. Ooh.
I have a question before we move on.
Yeah, I called.
And you could just So in the example of like estimate or predicting like housing costs, according to location? Is it like, are you just feeling like feeding parameters, or is it like probability based, like the most likely outcome out of a number of outcomes, or like what's the?
So it really depends on how you want to make the system. You have to remember that machine learning, you can use also just machine learning algorithms. Like linear regression is considered machine learning, even though it's not necessarily what we think of when we think machine learning. But so with that being said, you could make it statistics based. Like I don't know if you were there, Giovanni, but with the Naive Bayes classifier, still machine learning, but it's based on probabilities. And so then to make the best model, I'm not 100% sure what you would do because I've never done that project yet. But you could do a neural network, or you can make it like a classifier that's based on probability and so on. So
Gotcha. Cool.
Yeah. Thanks for
Thank
your
you.
question.
Yeah.
Okay, so move on. Any more questions? We good? Let me check the chat. Oh, did John join?
Jonathan is here.
Hey, John. Let me make you co-host. There you go. Yeah, John. John, you know, he was he had work, so you know, when work calls, that's always priority. But here, David says, and by the way, if I missed anything, please just resend it. I have no problem. I thought making a neural network to classify the MNIST digit pictures was the hello world of ML. It is. You could say that that's normally the most common first method, but there's nothing wrong with that. And even at a high level, if you'd like to go back, and that doesn't matter, because the concepts still apply very well into even at a higher level. And yeah. But yeah, it is very common. It's just like the cats and dogs. That's a very common one to go off first, is, you know, classifying whether it's a cat or a dog, because these are easy concepts to grasp, but they bring out a lot of ML topics and AI topics and deep learning sometimes, depending on how big your data set is and so on. But yeah. But yeah, that's true, John. It's more like an algorithm, but it's still considered machine learning. I don't know. That's been on the fence, I would say, but yeah. Okay, we continue. Let me just there we go.
Can I say something real quick? Sorry.
Yeah. Go ahead.
The MNIST dataset is the hello world of deep learning. Not machine learning.
We went over this, right? My bad. I forgot. Fair.
Yeah.
The AC machine learning, I didn't even notice. Yeah, I was gonna go into that. There's a slide in later on that it shows the hierarchy of things. I know we're actually behind schedule on the slides. We could go through it fast, but I think I like this. I like talking about it as much as it's needed, and there's no problem. Also because, you know, like we were expecting to do John and I, but if I'm on my own, then like it's fine to. I don't really care being behind of it, you know. So yeah, cool. But thanks for bringing that up, John. And so, quick recap. We've already talked about it a lot, so I don't want it to seem, you know, too much. But so rule-based approach, you have defined rules. It's kind of like just programming you saw with the pseudocode. And yeah, like you get your improvements from algorithms and networks. So it's still it doesn't mean that it's inferior to machine learning. We saw how there are different better applications where machine learning is more optimal and where rule-based approach is more optimal. Because you have to remember that machine learning sometimes, well, first it's very time consuming, and then it's very resource consuming too. And especially when you're doing it, an algorithm can be much, much faster. Yeah, so machine learning, it learns from data. So with the experience, again, I think I drilled it into your heads. And yeah, and like we saw with the QuickDraw, improvements can come from additional data. The more data you feed it, doesn't necessarily mean that it's going to get better, but generally it will get better. Okay, idea to implementation. I'm gonna skip this video. It's not a bad video. I can send it to you guys if you'd like, but I'm just gonna skip it for now. When we're looking at, this is the machine learning pipeline, really. And if you don't know what a pipeline is, it's very simple. To its core, it's just a plan. I guess you could consider a plan of how you want to go about doing something. So in this case, how we're trying to implement machine learning on something. So you want to think, if you're doing an application with the user, you do focus on the user. Then you think about, okay, what are you trying to do? What is your objective? Then you want to collect the data, prepare the data. That's always a very important step, but time-consuming step. You train and test the model after you create it, obviously. And then you predict how accurate you were, and is it good enough for what you're trying to do? Is it not? And then you can go back all the way back to the beginning to try to focus on what you're trying to aim for. Or you could say, okay, I need more data, or I need to see how it goes on other data. And then you go back to collecting data. Actually, I will play this video. I think it's good. It's the last video that I'm gonna be showing you. So enjoy.
Let's play a game. Close your eyes and picture a shoe. Okay, did anyone picture this? This? How about this? We may not even know why, but each of us is biased toward one shoe over the others. Now imagine that you're trying to teach a computer to recognize a shoe. You may end up exposing it to your own bias. That's how bias happens in machine learning. But first, what is machine learning? Well, it's used in a lot of technology we use today. Machine learning helps us get from place to place, gives us suggestions, translates stuff, even understands what you say to it. How does it work? With traditional programming, people hand code the solution to a problem, step by step. With machine learning, computers learn the solution by finding patterns in data. So it's easy to think there's no human bias in that. But just because something is based on data doesn't automatically make it neutral. Even with good intentions, it's impossible to separate ourselves from our own human biases. So our human biases become part of the technology we create in many different ways. There's interaction bias, like this recent game, where people were asked to draw shoes for the computer. Most people drew ones like this. So as more people interacted with the game, the computer didn't even recognize these. Latent bias. For example, if you were training a computer on what a physicist looks like, and you're using pictures of past physicists, your algorithm will end up with a latent bias, skewing towards men. And selection bias. Say you're training a model to recognize faces. Whether you grab images from the internet or your own photo library, are you making sure to select photos that represent everyone? Since some of our most advanced products use machine learning, we've been working to prevent that technology from perpetuating negative human bias. From tackling offensive or clearly misleading information from appearing at the top of your search results page, to adding a feedback tool on the search bar so people can flag hateful or inappropriate autocomplete suggestions. It's a complex issue and there's no magic bullet, but it starts with all of us being aware of it so we can all be part of the conversation, because technology should work for everyone.
Again, a beautiful video. I love this. I don't know. I feel like they're really good. What do you guys think?
Pretty cool.
Cool,
Really
right?
important introduction to the concept of like having proper data, why it's important.
I mean, yeah, exactly. Having proper data, I think that's an incredibly important step. And what's important, so they talked about that where you would think this is a machine that is training on data. A machine does not have, well, that's, right now, normally a machine does not have conscious, it does not have those biases that a human might have. You have all kinds of biases, whether you want to or not. That's just how experience goes. And that's more of an anthropology and philosophy thing. But it's very important because when you're trying to make a model and you're trying to perform a machine learning and AI in general, the entire part of AI, you want to avoid all kinds of biases that you can. Not only does it give you bad results, but it gives you inaccurate results. And so bias can come from like selection and how you pick it. But the important thing to know, and we'll go more in depth in the future if you guys are interested. But what's important to know is that there's bias everywhere, from what you input in as the data, from how you make the model, and how you define how you define what is a good result and how you fix it on your model. So everywhere along the way there's possibility for bias. Even if you don't mean to. If I put a data set, like they mentioned, trying to predict how a physicist in the past would look like, because there's bias in social cues, in gender, in physicists in the past, that biases your data because it's heavily weighted on the male side. So you're gonna most likely get a male physicist face. So it's very important to learn. So any questions? No questions? Okay. And
I have a question.
Go ahead.
Are there any examples of bias causing real problems in the real world? Perhaps.
Go ahead.
Yeah, is there an example, like perhaps like something's happened outside that we don't know about?
Yeah, from really big scandals, I can't really think of any right now. Maybe it'll come up, but it's very easy. If you start implementing, for example, facial detection, you can have that if you're darker in skin color, it's a lot harder for them to get your features, because it's just more difficult to contrast. And so you also have the bias of I'm making a facial recognition system. I feed, based on population, I just feed whatever I find. But if we have minority categories, you're gonna have less representation of them. Therefore, it's gonna be more difficult to maybe for the model to classify them. And let me think. There are all the time. I mean, not even talking about like looks or anything else where that goes into like, cultural bias and so on. Just bias in how you train the model. So I'm trying to think. John, you probably have a good example.
Yeah, Aldo linked something really cool. I know, like for example, there's been cases where like Amazon's hiring software was biased. Their AI was leaning a little bit more towards men, so there was a clear gender bias there.
Yeah.
Also, like AIs in like policing precincts. This is a big topic of conversation for government systems because there's something called positive feedback loops. What happens when you create a decision-based AI to like look for certain features and like find certain things in certain areas? Well, you're going to find wherever you're patrolling the most. You're going to, like, for example, with police, if you bias to target lower income communities or target to lower, let's say, let's target Miami-Dade over Broward. The more you look for crime in Broward, the more crimes you'll find in Broward in contrast to Miami-Dade. So there comes like that, which is called positive feedback loops. I know like this is a case as well.
Yeah, and that's really cool that you mentioned, because I remember looking at a video on that, and that's very important because, like John said, that's very clear example of bias. But maybe if you're not thinking about trying to identify bias, you might overlook this. And then it just a positive feedback loop where, of course, you're gonna find more crime because you're there the most, you know. And yeah. So very good. Thanks, John, for that question. That's a very important question. So yeah. Don't worry, guys. 15 minutes. We're gonna try to wrap it up. We're gonna go over. You know, we had more questions at the end, but I think we're gonna go over a few of these because these are cool. So artificial intelligence. This is very quick. I can go over this very quick. Artificial intelligence is the umbrella term, and what I mean by umbrella term is it encompasses machine learning and deep learning. So it's the broad term that includes everything. And really, how we define it is, in very simple terms, we define it as trying to get a machine to do what a human can, right? So that's what we're trying to do with artificial intelligence. And the hope is that you'll get better than humans, you know, because computers are already better in math, for example, than most humans, and so forth, so forth. Yeah, so then machine learning. So it's a subset. It comes from artificial intelligence, and machine learning is you're again trying to make a machine learn. No, you're making a machine trying to do something that a human would. And how you do this is normally you feed it the data, you feed it the examples, the experience that it needs to start knowing. And these can be classification systems and so on, but neural nets are normally under deep learning. And that's important to remember. That's actually my favorite parts about AI. I know John prefers more of the like algorithms, classification, because those are very important trees, which I'm not supposed to say, but we may or may not cover in the next semester. So you may or may not be tuned for that, but I'm not going to say. Yeah, so then a deep learning, again, subset of all of this. And deep learning has to do with big data. I'm talking 100,000, sometimes millions, depending on how big your data. I think it's classified that if it's over 30,000, it's considered big data, but I'm not 100% sure. I see the reinforcement learning. Yeah, I mean that's very important. I would say that's more in deep learning. Yeah, right, John. That's more in deep learning, reinforcement learning.
I would separate it because it's unlabeled data.
True. I don't know.
Yeah, reinforcement learning is within machine learning, though.
Mm-hmm. Yeah, that can.
Well, that's
but
where I
it's
would
not deep learning.
but...
Yeah.
Well, yeah, I guess that's a whole new other thing, but yeah. So deep learning. Think of neural networks. These are normally you have normally when you're talking about deep learning, because you're handling big data, you have complex networks and with many layers to try to be very accurate. So, and let me get this. Yeah, and so then that's what we see. We see big data, algorithms, and technology. When you mix it all together, that is ML. Or at least that's what it pertains to. There you go. Actually, John, do you want to do this part? I don't want to exclude you, man. You're already here. You know this part.
Oh.
Yeah.
Sure. I don't have the notes on me, but I'll just.
If you need me, I got you. I can do it.
Yeah, just talk about it. I'm unprepared.
Well, he's being humble because I know that if you ask John this, he knows it immediately. But of course, you know, he's. I threw him into this. But yeah, so we even talked about this earlier, but this is just classification. You're trying to find some kind of function, some kind of line that separates your data points. And then as you feed in more data points, if you stick with that line, so you're not changing it, you could change it, but let's say we stick with this line. As you feed in more data points, you'll be able to classify just based on that what kind of data you're dealing with. So like with a picture of a lion, it'd be, you know, a lion wildlife map. So very, very simple. It can get complicated, but normally not. Regression. So this is linear regression. I don't know if you guys remember. If you weren't there, we did cover this in one of the previous dev communities. And this is a really good GIF to kind of show you how it looks like. And one of the applications, which is really cool, is, you know, with travel times. What is the, it's a bit more complicated than regression because you have to consider, with a plane, it's less complicated, but you know, you have to consider roads and legality, and you can't just fly. But yeah, you're trying to find the line best fit, the line that gets you quicker to point A and B in this case. Clustering, it's almost similar to classification, except clustering, you're classifying into clusters. And so you have the different techniques for this. We will go, well, I can't say, but we might maybe perhaps go into this in the next semester. Just briefly trying to because this is really cool, and it does come up a lot in machine learning and in AI in general. And so yeah, your clustering values. So in here you see this is classic MNIST. So the sevens you're clustering in one group on how they look like. So I won't get too much into MNIST, but it's really interesting. You have different features that you can extract. Then with the twos, so you kind of group them together. Yeah. Sequence prediction. So this is really cool. And Lazaro, it's a pity that he's not here, but he told me, actually, no, it wasn't Lazaro, but Lazaro was there. John, he used to have an Android, and he said, you know, Android came out with this way before. Right, John? Yeah. And he said it came out way before that Apple did, because I was telling you, sequence prediction is so cool, you know? I mean, I'm really glad that Apple did it. Just maybe it's not something that I use on a daily basis, but it's definitely super cool, you know? And that also uses machine learning. So actually, Android was doing this way back. It kind of shows you they're better in some areas.
Yeah, Android was doing this like when I was in middle school, so like 2012, 2011.
That's impressive.
So, yeah.
Think about it, around 8 years of maybe a little less before Apple implemented it.
Yeah.
But yeah, cool. Style transfer, I have a good friend and a mentor of mine. He loves to teach this. He's much better at it, but it's really cool. So you take a picture and you take another picture. So in this case, it's a picture of a turtle and the great wave off Kagasaki. I don't know. I was just distracted because I was going to show you my phone case, which is actually that, but with pugs. You see the bugs? It's kind of old. Sorry, it's kind of chipping, but I don't know. I always liked it. Yeah, I guess style transfer. But yeah, so you're transferring in the top ones with the pictures. You'll see in the GIF, you transfer that kind of art that you have into the picture. This is normally you use a GANs, which is a general adversarial network, but that's very complicated, and we'd love to go over it some other time. Then we have style transfer in voice. This is also really interesting because you would think style transfer in images, very logical. Style transfer in voice. So this is, you have English male, English female, and Japanese male. And while I didn't really search for applications of it, I was talking to John about it, and we came up with a good implementation of this, and it's probably used. I said I was pretty sure they were using it. Excuse me, like for Siri, you have all these different accents, and it's incredible because you have to remember that it's a almost like a text-to-speech thing where they say the voice and they try to. So if it's Japanese, you need a Japanese accent, or it depends what language you're in, but you can transfer that type of voice so you don't have to go and record somebody saying a bunch of words over and over, right? So then we have all these questions, which I like to have a hard cap at 9:30 because you know, I don't want it to seem like we keep going over or something. So we have 5 minutes. Sorry, can't do any of these. If you want though, I'd love to do this with you guys because you know you guys are great. Rip, yes, it is. But we are nearing the end, and this is you know, the final slide. And so let's try to recap really fast because we have 5 minutes. Tell me, what is ML? Anybody except John, because I know you know it. Can't be cheating.
And except David.
Well, no. David can still go. It's good. Whoever wants to. Even John, if you want. I have no problem.
Trying to make programs do things that humans do.
That is very close. It is part of machine learning, but you could say the same about AI. What is specific about machine learning, Danny, that you would say is specific to ML? Do you remember?
Feeding it a lot of data and having the machine learn based on large amounts of data.
Exactly. Yeah, you're learning from experience. I mean, you're not learning, but the model is learning from experience, which is really data, and so on. So great job, Danny. You get a cookie, except I don't have cookies.
All right. So, question about that. Like in the very beginning stages of a model, would it need like human input to like, yes, this is like an apple or it's not, right? Kind of like a starting
The
point.
data would be labeled.
Oh, it's labeled. Okay.
Well, it depends, right? You have unsupervised and supervised. John, if you want to get in on this, I'm sure you can answer this better.
Yeah. For unsupervised, it requires so an unsupervised machine learning algorithm is basically a machine learning algorithm that is basically trying to learn distinctions between the data. So the data doesn't really require any manual labeling, whereas supervised does. This is why like clustering does best like for unsupervised tasks. And classification can be, actually, no, it can't. Classification is more so generally a supervised learning task.
So yeah, you see, Giovanni, actually, the answer is both. Because sometimes it depends how you want to train, and for different situations, you may need to label it. You know, like with what Google did, the Google AI engineers did with QuickDraw, you need to label that data classification. So yeah, thanks for the question. ML versus rule-based, I'd hope that you guys know that one because I really said it a lot of time, but let's see. What do you guys think? Anybody?
Let's get Clement to answer.
Oh, Clement.
Professor called on a student. Ooh.
Called him out. Well, maybe Clement's not there, but no worries, no worries. I think Giovanni was gonna answer. As I saw.
Who? Oh, me?
Yeah. Were you trying to answer or?
Yeah. So I think I guess rule based would be like it's deterministic, so you can like just like you could definitively know like the state, right? So like the payment processing, right? Like you start somewhere and you end somewhere, and the process, if it goes well, it'll be the same for the most part every time. So I guess L would be like where you're just trying to classify based on patterns or like similarities of like a aggregate data. I know that's the best. That's what I got from it.
No, that's really good explanation. I really like that, Giovanni. I can see you pay attention, and yeah, that's exactly it. You know, rule based. I mean, if you bring it to simplest terms, rule based, you're defining something. You know, you're making functions. You're kind of, I don't want to say put it in a box because it can still be very dynamic and very open. But ML is just better at changing like that, because with code you'd have to, if you want to implement something new or you want to do something new, you'd have to implement it manually, right? But yeah. Okay, so we are at 9:30, our cap. So I just wanted to say thank you guys for joining me. It was great. I loved today. I loved John was able also to join us at the end. And I love the discussion. Again, thanks to John, and thanks to you guys. I hope that you join us. Well, I know you guys will. I trust you. Into the new semester, we have a lot of things planned out. I think it's going to be super cool. Also, in winter break, I don't want the server dead. No, I like what you guys are doing in the chat and bringing up like Aldo was doing, bringing up these articles and things for all of us to learn. I mean, you have to remember that John and I, we love these articles because we're still learning from them. I mean, protein folding, I have no clue about that. So yeah, I want you to do that. And as a last thing to end on, I want you guys to tell me in the Discord chat, we'll move it on to there, what your favorite type of ML is that you learned. You know, classification, clustering, regression, sequence prediction, style transfer, anything else you might know. What is your favorite implementation of it? I'd love to hear it. And with that, I bid you goodbye. Take care, guys.
Have a good night, everybody. Take it easy.
All right.
Thank you.
Oh, thanks.
So-
You guys are crazy, yeah. Thank you. Have a great day. Bye, guys.